Hi, this is Mr. Chin. Today we're going to be going over how we can use tree diagrams to find the sample space. Alright, so recall from the old videos, the sample space are the possible outcomes for a probability experiment. Okay, and now we're going to be going into compound events. So a compound event is when two or more probability experiments are conducted together. Alright, so what that would mean is like we're flipping a coin and then tossing a number cube, or spinning a spinner and then flipping a coin, right? So it's basically two probability experiments or more. First example I want to go over is find the sample space for flipping a coin and then tossing a number cube. Alright, now to find the sample space of compound events, we can make a tree diagram. Now before we get into that, let's find the number of outcomes we should get when flipping a coin and then tossing a number cube. Now the way we find the number of outcomes is by multiplication. Alright, so we're going to multiply the number of possibilities for each experiment. So flipping a coin has two possibilities, that's going to be heads or tails. And tossing a number cube has 6 possibilities, that's the numbers 1 through 6. Alright, so if I multiply 2 times 6, we get 12 different outcomes, and this means that we should have 12 different combinations when making our tree diagram. Now remember, sample space is not the same thing as the number of outcomes, right? The number of outcomes is a number, right? So the number of outcomes when flipping a coin and then tossing a number cube, we should get 12 different outcomes. Now the sample space means we're going to list all the different combinations, right? Now if it was just a coin, we would just say the sample space is heads or tail. Or if we were just tossing a number cube, the sample space would be 1, 2, 3, 4, 5, 6. But now since it's two different things, the sample space gets a little bit trickier. And that's where tree diagrams come in handy. Alright, so let's pretend we flipped the coin first. So if we flip the coin first, we're either going to get heads or tails. Right? Now after we flip the coin, we're going to toss the number cube. Right? So when we toss the number cube, we're either going to get numbers 1, 2, 3, 4, 5, and 6. Okay, so I'm either going to get heads on the coin and 1 on the number cube, heads on the coin, 2 on the number cube, heads on the coin, 3 on the number cube, and so on. Alright, now what happens if we got tails first? Well, we would get tails and then 1 on the number cube, or we could get tails and then 2 on the number cube, or tails and then 3 on the number cube, and so on. Alright, so this is my sample space as a tree diagram. Now if I wanted to list all the samples out, or the combinations, all we need to do is follow the branches of the tree. So heads and then 1. So that means that's heads 1, and then we do the same thing for everything else. So this one means heads 2, heads and the number 3, heads and the number 4, and so on. Now if you look closely, this is 12 different outcomes, which matches what I have over here. Right? Okay, so let's do one more example. For dessert, you can choose 1 from each category. Alright, so you have 2 different pies, apple and cherry, 2 different toppings, whipped cream and wafers, and 2 different types of drinks, milk or tea. Alright, so first thing we're going to answer is find the number of outcomes. Well, if you look at the chart carefully, there's 2 things in each category. So if I multiply 2 times 2 times 2, you should get 8. So this means we're going to have 8 different outcomes in our sample space. Okay? So number 2, list out the sample space, find the combinations, assume you need to choose one thing from each category, all right, and only one thing. All right, so first thing I'm going to start with is the pies, okay? So we have a choice between apple or cherry. Now if we picked apple, we have a choice of 2 different toppings. So that's going to be whipped cream or wafers. If we picked cherry, we would have 2 different choices of toppings. Once again, whipped cream or wafers.
One eternity later.
Now once you pick your pie and then topping, you get to choose between 2 drinks. So if you picked apple, whipped cream, and now you have a choice between milk or tea. If you picked apple and your topping as wafers, your choice is milk or tea, and same thing with everything else. All right. Now, if I wanted to list out my sample space, once again, just follow the branches. So apple, whipped cream with milk. That's the first thing. And the second thing would be apple, whipped cream with tea, apple, wafers with milk, apple, wafers with tea. Alright? And do the same thing with the cherry pie. And that is what we get. Alright? Now, notice we have 8 different possible outcomes here, which is the same thing as what we have earlier for the number of outcomes. Alright, so this is my sample space. And before I end the video, I just want to say that the point of a tree diagram is just to make finding the sample space easier. Because if you had to find the sample space and you didn't have some organized method of doing so, right, it makes it very easy to miss one of these combinations, right? And that's something we don't want to happen. Alright, so thanks for watching and have a good day.